In this video, we will explain the rule of a device nodes and how they use major and minor numbers, the need for the udev methods, and list its key components. We're going to describe how the udev device manager functions. We're going to identify udev rule files and learn how to create custom rules. Okay, let's begin. udev. udev stands for User Device Management. It dynamically discovers built-in hardware as well as peripheral devices during system boot when hot plug it at any time. udev handles loading and unloading device drivers with proper configurations as needed, and its tasks include device naming, device file, and symlink creating, setting file attributes, taking needed actions. When devices are added or removed from the system, udev receives a message from the kernel. It then parses the rules.files in the etc udev rules.d directory to see if any rules are there for the device added or removed. These rules are totally customizable and can specify device file names, device file creation, specify symlinks to be created, specify file attributes to be set for the device file, including user and group ownership, and even specify actions to be taken, programs to be executed. System administrators can control how udev operations and craft special udev rules. Device nodes. Character and block devices have device nodes. Network devices do not. These device nodes can be used by programs to communicate with devices through nodes using normal I/O methods. A device driver may use multiple device nodes. Device nodes are located in a dev directory. Let me show you an example. ls-l dev, right, in this directory. Device nodes can be created with sudo mknode, right? mknode -m 666 dev my cd drive c254-1. udev components. udev runs as a daemon, either udevd or systemd udevd, and monitors a netlink socket. When new devices are initialized or removed, the kernel facility sends a message through the socket, which udev receives and takes appropriate action to create or remove device nodes of the right names and properties according to the rules. The three components of udev are the libudev library, which allows access to information about the devices, the udevd or systemd udevd daemon that manages the /dev directory, the udev adm utility for control and diagnostics. The cleanest way to use udev is to have a pure system. The dev directory is empty upon the initial kernel boot, and then is populated when device nodes as they are needed. When used this way, one must boot using an innate RAM FS image, which may contain a set of preliminary device nodes as well as the udev infrastructure. udev rules. udev rules files are located under etc udev rules.d, rule name.rules, and the user library udev rules.d rule name.rules with names like 30 usb.rules, 90 my custom.rules, 70 mos.rules, 60 persistent storage.rules, right? There are two separate parts defined on a single line. The first part consists of one or more match pairs denoted by ==. These try to match a device's attributes and or characteristics to save value. The second part consists of one or more assignment, the key value pairs that assign a value to a name, such as a file name, assignment, even file permissions, etc. Let's see some examples here. ls etc udev rules.d. You can see those different rules, 70 something, right? etc udev. Let's take a look at this rule. The example. Take a look at another rule. Cat GNOME. Look at this rule. Okay. Creating udev rules. The format for a udev rule is simple. Match OP value, assignment OP value, right? Rules files can be in 3 places, and if they have the same name, the priority order is etc udev rules.d, run udev rules.d, user library udev rules.d. There are 2 separated parts defined on a single line. The first part consists of one or more match pairs denoted by double equal signs. These will match a device's attributes and or characteristics to some value. The second part consists of one or more assignment of key value pairs that assign a value to a name, such as a file name, group assignment, or even file permissions, right? You can see some examples on the screen, bottom of the screen. If no matching rule is found, it uses the default device node name. You can always see man udev for explanation of the key values, such as same link and run, right? Examples of rule files. Let's see some example of rule files. If you have a Fitbit, right, you can see like that. The second one is the example for creating crash dumps in the fast kernel, loading with kdump kexec, right? And the third one is an example for KVM virtual machine hypervisor. Let's see the example here. Let's take a look at three rules here. We're gonna take a look at the first GNOME one on a core. Cat dc udev rules.d 70 snap core.rules. Second one gonna be GNOME. Alright, third one gonna be system monitor. Alright. Fourth one gonna be calculator. Major and minor numbers. The major and the minor numbers identify the driver associated with the device, with the driver uniquely reserving a group of the numbers. In most cases, but not all, device nodes of the same type, block, or character with the same major number use the same driver. Let's see an example here. Control L, -L. right? The major and minor numbers appear in the same place that the file size would when looking at a normal file. In this example, well, normal users will probably never need to refer explicitly to major and minor numbers and will refer to devices by name. System administrators may have to untangle them from time to time. If the system gets confused about the devices or has some hardware added at the runtime, the minor number is used only by the device driver to differentiate between the different devices that may control or how they are used. These may either be different instances of the same kind of device, such as the first and second sound card or hard disk partition, or different modes of operation of a given device, such as different density floppy drive media. Device numbers have meaning in use space as well. Two system calls, MK node, and a stat return information about major and minor numbers. udev and a hot plug. As devices are added or removed from the system, working with the hot plug subsystem of udev acts upon notification of events to create and remove device nodes. The information necessary to create them with the right names, major and minor numbers, permissions, etc., are gathered by examination of information already registered in the sysfis pseudo file systems, mounted as a sys and a set of configuration files. The main configuration files is etc udev.config. It contains information such as where to place device nodes, default permissions, ownership, etc. By default, rules for device naming are located in etc udev rules.d and the user lib udev rules.d directories. By reading the main page for udev, you can get a lot of specific information about how to set up rules for common situations. The udev device manager. When udev receives a message from the kernel about devices being added or removed, it parses the rule setting files in etc udev rules.d *rules and the user lib udev rules.d *rules to see if there are any rules relevant to the device being added or removed. It then takes appropriate action, including device node naming, device node, and symbolic link creation, setting file permissions and ownership for the device node, taking other actions to initialize and make a device available. These rules are completely customizable. Okay, this is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.